So you've signed up for an online chemistry class and you have an online virtual lab. But the problem is you don't know your Erlenmeyer flask from your volumetric flask. You don't know your barrel pipette from your graduated pipette. Or you don't know your reaction vessel from your graduated cylinder. Not a problem. With these series of videos, I'm going to introduce you to the labware that is very typical in a chemistry lab, so you'll actually be able to see what the devices actually look like and how to use them, besides just seeing the virtual diagrams of them and manipulating them in the lab. So stay tuned, like and subscribe to this channel and to this video, and you'll see a series of videos incorporating the electronic balance, volumetric glassware, and then various other equipment such as these ovens that are behind me, magnetic stirrers, hot plates, and how to use those. And that will help you manipulate them in the simulations for the laboratory, as well as when you actually get into a real chemistry lab with real equipment. Hi, today what we're going to do is we're going to take a look at different scales and balances. Now, a lot of people use those two words interchangeably, a scale and a balance, but really they're two different things. What a scale does, for instance, one of these spring scales that we might use in physics class, not too much in chemistry, but more in physics, it's going to find the weight, which is what a scale does. The weight is the amount of gravity pulling down on the mass of an object, where as opposed to that, a balance, for instance, this triple beam balance here, it's going to actually balance two things out where you have a mass on each side and it's finding the total mass. So to give you an example of that, I have a meter stick here and it's somewhat balanced right on the middle. If I take a mass and I put it on one side of the balance, it pushes it down on that side. If I take an equivalent mass and I put it on the other side of the meter stick, and we move it around a little bit, we can get it to balance. So now it's balanced. So that's what the term balance really means. And so a balance is going to find mass, whereas a scale is used to find weight. Now, we're all at normal Earth gravity, so it really wouldn't make a lot of difference. But if I took this spring scale and I attached a 20-gram mass to it, it's pulling down and it's saying that it has a mass of 20 grams or about 0.8 ounces. If I took this exact same scale, took it to the moon where there's only 1/6 as much gravity, this would only weigh 3.33 grams or have a mass of, say, I have a mass of 3.33 grams because it uses a spring inside. And the spring is being pulled down and it moves the pointer here on the scale. Now, all balances, you need to be able to zero them out. So this one has a little tab on the top and you can slide it up and down to zero it out. Take this triple beam balance, you can see that it has a pan on this side. Here's actually where the pivot point is. If I take a 200-gram mass and I place it on the pan, to get it to balance, I have to slide the weight over and lock it in. And it's reading right around 200 grams now. If it weighed a little more or a little less than that, say, for instance, instead of weighing a 200-gram mass, say, I want to weigh a quarter. So to find the mass of a quarter, the quarter is on the pan, I would move this over, and it weighs less than 10 grams. So I don't want to use the 10 gram, so I'll slide this one over until I get the pointer to settle or balance right about on the zero line there. Let it dampen out. So a quarter weighs about 5.5 grams. So a triple beam balance is used to find the mass of an object, not its weight, because it's balanced. And if we took this to the moon, it would still have a mass of 5.5 grams. Now, an electronic balance, there's an electronic balance. This one is actually a postal scale. So it's called a scale because it has a pressure plate in here and it's using springs very similar to the spring balance did. As it pushes down on the pressure plate, then the electronics are able to convert that weight into a mass. Now, this one is nice and this fairly large display on there. So I'll come around to the front, show you how this one works. So what we do is we press the on-off button. Once we have it on, it's counting down then. And as it counts down, it's going to read 0. Now, this one we can actually toggle it between the different settings on there. So this one is in pounds and ounces. There's kilograms, there's pounds, there's ounces, there's grams again. If I take that exact same quarter and I put it on the balance, we can see that it rounds it up. This one only goes to the nearest gram, so it rounds it up to 6 grams. 5.5 would round up to 6. If I take the 200 gram mass and I put it on there, it weighs 200 grams. So it's a fairly precise balance and it's also being accurate. Now, when we're actually going to find the mass of an object, we're not going to weigh it directly or place it directly on the pan of the balance, especially if it's a liquid. And so what we're going to do is we have to put something in there in order to capture what we're trying to find the mass of. And so in this case then, I put a beaker on there and the beaker has a mass of 30 grams. We could record the mass of the empty beaker, add our material into there. Let's put my quarter back into there again. And subtract off the mass of the empty beaker. So that would give us 6 grams for the quarter. Now, an easier way to do that is we use this button here, which is the tare, T-A-R-E, or 0 button. When you press that button, it zeroes out the mass of the object that's sitting on there. In this case, it's a beaker. And then when I put the quarter in, it has a mass of 6 grams. Now, what you have to do is make sure that when you actually take this off, it's going to go to a negative value. So we can see over here, it says negative 30 instead of 30. So we press tare again, and it will zero that out. Now, in order to make sure that this is actually reading correctly, we have a standard, and this standard is a 200 gram mass, and they're very, very carefully calibrated. I'm going to use this so I don't touch it with my fingers, so that way the oils from my fingers don't get on there. And I place it on there, and we can see that it weighs 200 grams or has a mass of. Now, this is the type of balance that you're typically going to see in the chemistry laboratory. It goes out to 3 decimals, and it has a draft shield because this one is so sensitive that it goes out to the nearest milligram, that if I wave my hand over the top of it, it will actually change the reading on the scale. And so simply by waving the air currents over the top, that is the purpose of the draft shield. So we do not want to find the mass of something directly on the pan. Obviously, if it's a liquid, it's going to run all over. If it's a solid, we're never going to get it all cleaned off of there. It may damage the balance as well. And so what we're going to do is we're going to use some weighing paper. Sometimes, alternatively, you'll have a weighing boat. And here's a neat little trick. If you have the weighing paper, is fold it over one way, increase it, open it up, fold it the opposite way, increase it. And now what you've done is you've made a little boat, so that way when you measure out your solid, it's going to be really easy to pour it into your beaker, flask, whatever it happens to be, without spilling it. Put the draft shield back on. Now, the paper does have mass. We can see it as mass of 0.432 grams. Well, we want to get rid of that 0.432 grams, just like we did with the beaker on the larger balance. And so we press the re-zero. So we zero it out. We get rid of the mass of that weighing paper. I'll take that same quarter, put it on there, replace the draft shield. And now we can see that it's 5.705 grams. This last digit sometimes will bounce around a little bit, so you kind of got to guess where that last digit is in order to make sure that it is as precise as you can actually get it. Okay, now to make sure that this is actually reading how it's supposed to be reading, we'll take our quarter off and our weighing paper, replace our draft shield, press the re-zero. There's a calibration certificate on the side. So typically what happens is either the laboratory director or an outside company will come in. They'll use a standard mass, just like my 200 gram standard here that I used on the other one. And they'll actually zero out the balance. Now this one says that it has a mass of 200.023 grams. So 23 1,000ths over the 200 grams. Now chances are that's because I haven't been as careful with this one. I've used it quite a bit and I've picked it up with my fingers a couple of times, and it probably has some oils from my fingerprints on there, a little bit of tarnish. So if I polished it up, it would probably come back and read the 200.0 grams again. But it's pretty darn close. A lot more precise than either our postal scale or the triple beam balance. So what we've seen is we've gone from our precision balance here, oftentimes called an analytical balance, our triple beam balance. Here we have our digital scale, which is a lot more precise than the spray scale is, but pretty much it does the exact same thing. So these are the various different types of balances and scales that we'll be using in the chemistry laboratory.